Hello students, I Deepak Somani, Assistant Professor, Department of Electrical Engineering, SS College of Engineering, Udaipur, Rajasthan. Today I going to cover the topic torque equation of an induction machine. Torque equation. The torque equation produced by three-phase induction motor depends upon the following three factors. Following three factors means it is depend on the rotor current, power factor, and rotating magnetic field. Rotating magnetic field, which is responsible to produce induced EMF in rotor. The equation becomes T means torque is directly proportional, phi means flux, I2 rotor current, cos theta 2, which is power factor. 2 is denote rotor side and 1 is denote stator side. So torque is directly proportional to rotating magnetic field, which is responsible to induce EMF, I2 rotor current, and cos theta 2 power factor. The flux phi, the flux phi, which is directly proportional to stator EMF, which is directly proportional to phi is directly proportional to induced EMF in stator side. So from transformation ratio, K is equal to E2 by E1 means secondary voltage to primary voltage. We can say that phi is directly proportional to E1. So we can put the value of K means we can phi replace by at E1. So K is equal to E2 by phi. So E2 is equal to phi. Rotor current I2. Rotor current I2 is equal to E2 by Z2 means E2 is induced EMF and Z2 is impedance of rotor side. We can put S. S means slip. S means slip. Induction motor depends on slip. So we can put S, E2. Here Z2 is equal to root R2 square R2 square. Z2 is equal to root R2 square plus S x2 square. R2 plus Sx2 square, where S is slip of induction motor. So we can put the value of Z2 SE2 upon root R2 square plus Sx2 का square. We can also put the value of power factor. Okay, power factor means R upon Z. Cos phi is equal to R upon Z. We can put the value of 2, so R2 upon Z2. So we can also put the value of Z2, root R2 square plus Sx2 square. So the value of I2 and cos phi 2 is putting in the torque equation. So T is directly proportional. We can put T is directly proportional phi I2 cos theta 2. We can put the value of I2 and cos theta 2. And phi is directly proportional to E2. So the equation becomes T is directly proportional to E2, I2 and cos theta 2. So the equation becomes T is equal to K as E2 square R2 upon root R2 square plus Sx2 का square. Okay, so we can put proportionality constant K and the equation becomes T is equal to SE2 square upon into R2 upon R2 square plus Sx2 का whole square. Here the value of K is equal to 3 upon 2 pi ns Newton meter. Ns is synchronous speed. So this equation is called developed torque. This equation is called developed torque by induction motor. Next, starting torque and maximum torque. Starting torque and maximum torque. We know that at the start the rotor speed n is equal to 0. So slip means ns minus nr upon ns. Here ns is synchronous speed, nr is rotor speed. So we can put the value of at the starting nr is equal to 0. So ns by ns is equal to slip is becomes 1. So this condition is called standstill condition. This is also condition is called standstill condition when s equal to 1. So T is equal to E2 square upon R2, R2 square plus Xx2 into K. This called is K, Newton meter. This is called starting torque when slip s equal to 0. Next, maximum torque. Maximum torque. To find maximum torque, we can differentiate torque with respect to slip. We can differentiate this equation with respect to slip. So, using the formula of U by V, we can calculate maximum torque. So, this is U part, this is U part, and this is V part. So, formula is there, differentiate of U by V, V square, V as it is, differentiate U with respect to x minus u differentiate v with respect to x. So u is this and v is denominator. Here differentiate with respect to ds, so v square. So v square u differentiate v minus v differentiate of u. So equation becomes with respect to s, r2 is 0 and s square becomes 2s minus r2 square is equation k is constant, e2 square is constant, r2 is constant, ds by ds is equal to 1. So equation becomes as it is k as e2 square r2 2s x2 square minus r2 square plus s x2 square. This becomes k e2 square r2 because ds by ds is 1. So we can multiply this equation 2s x2 square from this and r2 square plus s x2 square k e2 square r2 multiply. The equation becomes k as e2 square x2 square because these factor and these factor. So the remaining part is k as square k x2 square e2 square r2 square minus this. So k and e2 square is constant. So equation becomes k s square x2 square minus r2 square is equal to 0. S square is equal to r2 square by x2 square. This is called maximum slip. This is called maximum slip. So the equation becomes maximum torque is that because we can put the value of slip r2 by x2. So the equation becomes T maximum is equal to k e2 square upon 2 x2. So maximum torque is inversely proportional to the rotor reactance and it is maximum torque is independent of rotor resistance. Thank you.